Hello children, in continuation with the chapter circle, we will do few more sums from exercise 17a. We did till 5th sum. Now I'll start with the 6th one. The 6th question says, in a circle of radius 17 centimeter, two parallel chords of lengths 30 centimeter and 16 centimeter are drawn. Find the distance between the chords if both the chords are on opposite sides of the center, and the second case is on the same side of the center. So the question says you have a circle of radius 17 centimeter. So here if you see, this is a circle with center O. OA is the radius and OD is also the radius. Okay. And two parallel chords. So I have drawn the chords AB and CD. And it is given that the length of the chord is 30 centimeter and 16 centimeter. So AB is 30 centimeter and CD is 16 centimeter. Find the distance between the chords if both the chords are on the opposite sides of the center. So the first case is the chords are on the opposite sides of the center. So AB and CD is placed on the opposite sides of the center. You have to find the distance between the chords. So you are supposed to find PQ, that is the distance between the chords. Now AB is equal to 30 centimeter and CD is equal to 16 centimeter. So AP will be equal to PB, perpendicular drawn from the center of the circle bisects the chord. So this will become 30 by 2, 15 centimeter. Similarly here CQ will be equal to QD is equal to 16 by 2, which is equal to 8 centimeter. So this is 15, this is 15, 8 and 8. Now we have two right angle triangles. First is OAP. OA square is equal to OP square plus AP square, which is 17 square is equal to OP square plus 15 square. 289 minus 225 is equal to OP square. OP is equal to root over of 64, which is equal to 8 centimeter. So you get the value of OP as 8 centimeter. Similarly, you have one more triangle which is OQD. This is also a right angle triangle which is right angled at Q. So according to Pythagoras theorem, you get OD square is equal to OQ square plus QD square. OD is your radius, 17 square is equal to OQ square plus 8 square. 289 minus 64, which is equal to OQ square. This is 225 and therefore OQ will be equal to 15 centimeter. So you have got OP and OQ. So we can find PQ, which is equal to OP plus OQ. If you observe, OQ has OP and OQ, which will give you 8 plus 15, which is 23 centimeter. So the distance between the chords will be 23 centimeter if they lie on the opposite sides of the center. Now the next case is when the chords are on the same side of the center. So the second case is when the chords are on the same side of the center. So this is your center O. AB is a chord of 30 centimeter and CD is a chord of 16 centimeter. and here they are lying on the same side of the center. You have to find the distance between the chord. That means you have to find again PQ. Now the radius of the circle is 17 centimeter and AP is equal to PB is equal to 30 by 2, which is equal to 15 centimeter. Similarly, CQ is equal to QD will be equal to 16 by 2 is equal to 8 centimeter. This makes an angle of 90 degree. The perpendicular drawn from the center bisects the chord. So again you have two right angle triangle OAP and the other one is triangle OCQ. So in triangle OAP, according to OA square is equal to OP square plus AP square. You know OA is the radius, so 17 square is equal to OP square plus 15 square. 289 minus 225 is equal to OP square, and OP is equal to root over of 64, which is equal to 8 centimeter. Similarly, in triangle OCQ, which is again a right angle triangle, OC square is equal to OQ square plus CQ square. We know CQ is 8 centimeter and OC is again the radius, and CQ will be equal to 8 square. 289 minus 64 is equal to OQ square, and OQ is equal to root over of 225, which is equal to 15 centimeter. So we will find out the distance between the two chords, which is PQ. So if you see, PQ will be equal to OQ minus OP, that is 15 minus 8, which is equal to 7 centimeter. Moving on to the next sum, that is your eighth sum, which says a chord CD of a circle whose center is O is bisected at P by a diameter AB, and given OA is equal to OB is equal to 15 centimeter and OP is equal to 9 centimeter, we have to find the length of CD, AD and CB. So if you have to find CD, first thing you have got here CP is equal to PD, because again the perpendicular drawn from the center of the circle bisects the chord, and OA is equal to OB. If you see, OA is the radius of the circle, which is 15 centimeter. So you will have OC also as 15 centimeter and OP is given as 9 centimeter. So we can find, this is P, we can find CP here. So you have a right angle triangle OCP. In triangle OCP, according to Pythagoras theorem, OC square is equal to OP square plus CP square, which will give you, this is 15 square is equal to 9 square plus CP square, 225 minus 81, which is equal to CP square. This is 144 is equal to CP square, which will give you CP is equal to 12 centimeter. So you get CP as 12 centimeter and CD will be equal to CP plus PD, and you know CP is equal to PD, which is 12 centimeter each. So 12 plus 12, which is 24 centimeter. So the first thing we have found is CD, which is equal to 24 centimeter. Now we have to find AD. So you can join AD using a ruler. And if you see triangle APD, triangle APD is also a right angle triangle. So triangle APD, you can use the Pythagoras theorem, which will give you AD square is equal to AP square plus PD square, and therefore AD square will be equal to, now if you observe the figure, AP includes OA and OP. So this is OA plus OP the whole square plus PD is 12. So this is 12 square. So AD square, and OA we know it is 15 and OP is 9 plus 144. This is 15 plus 9 is 24. 24 square is 576 plus 144, which will give you as 720. So AD will be equal to root over of 720, which can be split as 9 into 16 into 5. So this is 3, 4, 12 root 5 centimeter. So your AD is 12 root 5 centimeter. Now moving on to the next part, which is CB. You have to find CB. So we can join CB using a dotted line, and if you observe here, you get CBP is also a right angle triangle. So triangle CBP is a right angle triangle. So by Pythagoras theorem, you get CB square is equal to CP square plus BP square. And CP square, what is CP square? It is again 12 square plus BP square. Now BP square will be OB minus OP, which will give you 144 plus OB is 15 minus OP, which is 9 the whole square, which is 144 plus 36, which is equal to 180. You get CB is equal to root over of 180, which can be written as root over of 36 into 5, which will give you 6 root 5 centimeter. So this is the way you have to find out each length. Now moving on to the next sum, that is your ninth one. The figure given below shows a circle with center O in which the diameter AB bisects the chord CD at a point E. If CE is equal to ED is equal to 8 centimeter, EB is equal to 4 centimeter, you have to find the radius of the circle. So if you have to find the radius of the circle, we will take the radius as x. So let OB is the radius and OD is also the radius. We can join OD also. So let OB is equal to OD is equal to x. So this is your x, this is your x, and EB is 4, and here it is a right angle, and it is given EB is equal to 4 and CE is equal to ED is equal to 8 centimeter. So this length is 8 centimeter. Now since OB is x and EB is equal to 4 centimeter, OE will be equal to x minus 4 centimeter. Now in triangle OED, which is a right angle triangle, by Pythagoras theorem, you can say OD square is equal to OE square plus ED square. So OD square is x square and OE is x minus 4 the whole square plus ED is given as 8, which will be equal to 8 square. Solving this, x square is equal to x square minus 8x plus 16 plus 64. X square and x square gets cancelled. 8x is equal to 80. X is equal to 10 centimeter. So you have got the radius of the circle as 10 centimeter because the radius is OB and OD, which we have taken it as x. Now moving on to the next sum, that is the 10th sum. Here you have O as the center of the circle. AB and CD are the two chords of the circle. OM is perpendicular to AB and ON is perpendicular to CD. So this is given, it is perpendicular, and AB is 24 centimeter, OM is 5 centimeter and ON is 12 centimeter. So this is 5 centimeter and ON is given as 12 centimeter. We have to find the radius of the circle and the length of the chord CD. So we can join OA, which is your radius, which you have to find, join OC. Now AB is given as 24 centimeter. Now since this is a perpendicular, it will bisect the chord. The perpendicular drawn from the center bisects the chord. So AP will be equal to, it is M. AM will be equal to MB is equal to 24 by 2, which is equal to 12 centimeter. Now in triangle AOM, this is your triangle AOM. By Pythagoras theorem, OA square is equal to AM square plus OM square. So OA square will be equal to 12 square plus 5 square, which is 144 plus 25, 169. So OA will be equal to 13 centimeter. So you get the radius of the circle as 13 centimeter. Since OA is 13, OC will be also 13 centimeter. Both are the radii of the same circle. So this is your 13 centimeter. Now again we have one more right angle triangle, triangle ONC. Applying Pythagoras theorem for this, you get OC square is equal to ON square plus NC square. So you know OC is the radius. 13 square is equal to 12 square plus NC square. 169 minus 144 is equal to NC square, which will give you NC as 5 centimeter. So if NC is 5, ND is also 5. So CD is equal to NC plus ND, which is 5 plus 5, it is 10 centimeter. So this is the 10th sum. I hope you have understood the concept of circle. Thank you, children.